Okay, welcome back to another video. This video today will be really interesting. As you see on the title, we have a video card that costs $1,500. With a normal price I could get this card, but usually this card comes from $2,500 up to $3,500. And we suppose that this card should be better than the 2080 Ti, and in terms of for gaming, of course. But this is not a gaming card. This is a Tesla card. It's the Tesla T4. It's a small form factor from Nvidia, meant to be for deep learning. It has the Tensor cores, it has a RT cores, CUDA cores. It should give you better performance at a low water consumption. So without further ado, this is the video card. So the Tesla T4, as you can see here on my hand, is a pretty small video card. We have a sleek design, and the thing I like on the back is, as you can see here, it said Tesla T4. This thing looks really cool. Talking about just how the video card looks, right? And then on this side we have the heatsink, and heatsink is it goes from the front and to the top to the bottom, from the front to the back. We don't have fans on this video card, so it's just a heatsink that goes from the front to the back and is bidirectional. So it means that you can pull air, you can push air from here and also push air from the back, and both will cool down the video card. Now this is more factor of the video card. It should give us better performance in terms of deep learning, of course, and you know the channel is getting more and more involved in the deep learning workstations, and also for benchmarking. This video card small form factor here has 16 gigs of memory RAM. That's why it's so expensive. That's why the price on it. And for just 70 watt consumption, you can get similar performance of what you get in the 2080, but you will get more VRAM here. And why VRAM is important on deep learning? Well, depending on the model you're working at, you maybe want to use FP32, FP16, and different kind of batch size. So if you're using a batch size of 64, it will fit the performance. It will fit on the memory of let's say 8 GB video card. But if you want to work with 128, you most probably will need a 2080 Ti, which has 11 GB. And here it will stop for people that want to work with something better. Because usually the next step will be the Titan RTX, which is 24 gigs of RAM, but that video card consumes 300 watts. And as you know, because of the design of the video card, the only way to put on the server or in a workstation will be going water cooling. But if you want to, but with this video card, you have something on the middle. So you have 16 gigs of RAM, which is enough to even run, some models have 256 batch size, and it will be perfect for that. It's a small form factor, just consumes 70 watt, and you just need to have a good airflow in front of the video card to cool them down. Thinking about motherboards, so for example, if you have a motherboard, let's say like the Asus Sage, which has 7 slots on the motherboard, you can connect up to 7 of these video cards. You can connect one by one. You don't need to do any modifications like doing water blocks, changing the backplate on the normal video card, because usually they use 2 slots and you need to have just 1 slot, then going water cooling, and connecting all those 7 video cards with water cooling, it could be a pain, and also it will takes a lot of money to do that. With this video card you can save some money if you buy 7 of them, connecting on the case, and they will work perfectly. Now we're gonna do a quick test. Usually the test we do here is using our DLBT app that you can, like I said before, you can download on the link below if you want to test and stress out your video cards for deep learning. That, by the way, will work if you are a gamer too. And we're gonna see the performance on this video card on different models. All right, the most important ones, the most usual ones, like for example ResNet, AlexNet, we have RexNet 50, and a different ones. We're gonna see the score, the performance, the temperatures on a normal desktop computer that we have, and we're gonna be comparing it with the 2080. Keep in mind that this video card, it can be used for 3D rendering, for deep learning, any kind of application, that simulations, any application that you use the CUDA cores or the RT cores on this video card, you can use it for. As you can see on the back, we don't have I/O, so we don't have display port here, but usually since you will be working with the server, it will be headless, or you can connect through different applications. So most people ask why Tesla video cards are so expensive. So the first thing you need to realize is it's an enterprise level video card, right? It's not a consumer side. So you may have a few features here that you don't have on the Geforce side. So for example, the most important one is vGPU, and with Grid It's a technology that Nvidia implemented on this video card, and you can create virtual machines that can utilize the video card as a vGPU, so virtualized GPU. Let's say, for example, you have this video card, and then you have 5 developers, right? And you want to have all those developers using that video card, and it's cost effective to have and split this video card between 5 people so they can use and create the model that working on, doing some small doing some testing on it, and once they can combine in one machine and use the full power of the video card, or have 5 people working on it. If you have different software, like for example, if you want to have virtual machines but they will be browsing on the web doing just lighting task, you can use this video card and apply 1 GB per each of those machines, and you will have 16 computers. So at the end, that's why it's expensive sometimes, because you get the cost effective once you want to use it for professional applications. One important factor here in this video card is that you have almost the performance, let's say, of the 2070, a little bit more. If you compare the CUDA cores, the Tensor cores, and the performance in general, the clock speed and everything, it's like a 2070, a little bit better, but with the option that you don't have any power connectors on the top. You utilize just the PCIe power to give you the same performance of the 2070, a little bit more, I would say. And also remember, keep in mind that this video card will work at 70 watt maximum. So we just connect it to the same way we connect any other video card. And lens, we're gonna test it. Now here we're gonna be using the HDMI to the motherboard, because if we connect it, because there is no way to connect it here on this video card, but we're gonna be utilizing the power, the graphic power from the video card, and just the output from the CPU. Okay, so now we're gonna be running the test, and what we did was very simple. We connect a 2070 video card and the Tesla T4 in order to compare these 2 video cards. So why we are comparing these 2 cards? The first thing is that because if you look at the specs of the Tesla T4, is similar in terms of CUDA RT cores than the 2070. 2080 is a little bit better, and the 2080 Ti is too much. We have to consider on prices here that, for example, the Tesla T4 we're talking about earlier, that was $1,500, what we paid for it, almost $1,600, and usually the price of this card can be up to $2,600 or $3,500. The 2070 is a Geforce card. It's intended for gaming, but since it has RT cores on it, it will give us the same kind of performance test, and we can see which one is better in terms of pricing, right? One thing to consider here is that the Tesla has it doesn't have any air cooling, and just a heatsink on it, and the Geforce RTX 2070 has 2 fans air cooling on it. Tesla T4 is meant to be for server, and G4 is meant to be for anything, and it's meant to be for desktop computers. So the test we're gonna be running here is ResNet 50. It's one of the latest Tensor. It's built in with one of the latest Nvidia Docker containers with the TensorFlow. And we're gonna be testing ResNet 50 to see images per second. Now, 2 important thing here is the batch size. And the number of iterations per second. The number of iterations we're gonna be running this test. The longer the number, more impact will be on the video card in terms of performance, thermal throttling, and also temperatures. So we're gonna be checking that on those 2 video cards. For iterations, we're gonna be running at 200 iterations, and the batch size we're gonna be running at 64. We can run more batch size on the Tesla T4 because it have more gigabytes, 16 gigs, compared with the RTX 2070, which is just have 8 gigabytes. So we're gonna be testing here, and let's see what happened on it. Let's see the score. Okay, so the card we have right now, as you can see here, is the Geforce RTX 2070. This card has 185 watt compared with the Tesla, which is just 70 watt. The temperatures right now is 31 Celsius, and the fan speed are running at 40%. The total memory is 8 gigs of RAM, and we're utilizing nothing right now because we're gonna be running the test right now. The driver version we're using is 430 latest, and CUDA version is 10.1 in order to run this test with the latest version of TensorFlow. Okay, we're gonna go here. It's already loaded, so we're gonna go to the settings. Yeah, quick thing here on the settings, the most important is number of GPU. We're gonna be running just one this time. The byte size is 64, and the number of iterations right now we're doing is 200. Okay, we're gonna be running it and see what performance we get. So right now we start at 173 images per second, and here we're gonna monitor the video card. So as you can see, it's utilizing the full power of the video card, 185 watt. Temperatures right now is 50 Celsius, 51, and it's utilizing 8 gigs of RAM, the total amount of the RAM that is available on this video card. And the GPU is being utilized 97-99%. That's why I referred before that if you want to use this test, we have a GUI interface for deep learning benchmark, which is just like clicks on the mouse. You don't need to do any terminal, any command line. You don't need to learn nothing like that. It's a pretty simple benchmark like the other ones you have for 3D rendering or gaming, and you can run it any Linux computer. We also have a guide on how to install everything, so we provide everything for it, and support. So you can send an email to us. You can check the website, it's technopremium.com. So right now we're seeing here is 170 images per second, and we see pretty stable. Once you see the card is getting thermal throttling after a while, you see that performance would drop. Let's say you're making 170 now, and then you will be making 140, 130 because of the video card is getting hot. In this case, it keeps the temperature fine up to 51, 56. Like I said, for 200 iterations, just one video card, and the average was 171 images per second. Now we're gonna switch on to a different card. We're gonna switch on to the Tesla T4 now and see the performance we get on that GPU. Okay, as you can see here now, we're running the same test again, but this time we're using the Tesla T4. We already connected on our computer. We remote connect to it through SSA. Alright, so as you can see here on the right side, we have the utilization of the GPU is 14 gigabyte. Almost the entire GPU is being utilized, and the power consumption is 70 watts. Right now temperatures is around 55, and that's with a normal desktop computer without any extra cooling, just the fans in front. As you see that the video card is getting really hot pretty fast because no active air cooling on it. This video card, like I said before, is meant to be for servers. So right now you see you're losing performance. We start at 110, and then we are already at 89 on the number on iteration number 172. And the video card right now is 85 degrees Celsius already, and that will impact a lot in performance. It will start throttling, and we will lose image per second. So you see here we went from 89 to 23, and it's getting very slow to do the calculation. Why? Because we don't have proper cooling on a desktop environment. I think for the price we pay for this card, Nvidia, it should include the air active cooling on it. That's the minimum they could do. It's a good card for the water consumption, 70 watts, great performance, but you lose a lot of that performance once you start doing the training for a long period of time. So at the end, you see, at the end we have 23, and if we run longer, this will keep dropping, the average performance will be even worse. Now we run it 200 times, and that's why the average was 193. 93 compared with 176 on the 2070 is a huge difference. As you can see, the temperature is still 86. If you run it for 20 minutes, it will be even worse, and it will take a while to cool down the video card because again, no air active cooling. Okay, to finalize this video, I would like to say that buying the Tesla T4, it doesn't make any sense. If you're trying to build a computer for deep learning or 3D rendering, it doesn't make any sense to go with it because you spend too much money and losing a lot of performance and compromise temperatures. For example, the test we did already, the 2070 is a video card that right now you can buy for $300, $349 on the on the second-hand market, or you can buy the 2070 Super, which give you a better performance for $499. So $500 compared with the Tesla T4, which is $1,500 that I couldn't find on eBay, is a $1,000 gap that you don't want to spend on it, because instead of that you can buy another two more, let's say RTX 2070, and in that case you will have three RTX 2070 to triple the performance of just one, and much more than the Tesla T4. This video card are meant to be for a service like Google Cloud, Amazon Cloud. They implement these GPUs on the server because it utilizes 2 units on the rack mount, and that's why it makes sense for them. And also they use it to share the video card. So like I said before, the only big feature that I see from the Tesla video card is that you can actually create vGPUs, so virtual GPUs, and so many people can connect and use the same GPU. And that's why Amazon and Google Cloud, they use that GPU for multiple users and they can connect at the same time. That's the only way it makes sense for them to offer this video card for customers, right? So if you're thinking about deep learning or workstation, this channel we're gonna be testing all the video cards, different performance, different tests. Don't forget to subscribe to see more videos like this. Hit the like button, that really helps the algorithm of YouTube so we can recommend our videos to more people. We're doing more videos every week. Let me know if you like this video, and I catch you on the next one. Thank you. Bye bye.